So in this video, we're going to talk about quadratics in standard form, and I just want to do a little caveat. At this point in our Algebra 1 class, we haven't learned how to find exactly where the x-intercepts are. So when I ask you to do a standard form equation, I'm really just looking, can you identify the y-intercept, can you identify the vertex, and can you draw the correct shape? Soon we'll do the x-intercepts, but we're not doing that. So if you watch this video out of order, you might be like, why isn't he finding the x-intercepts? Okay, so here's all we're going to find. The y-intercept is just plug in x equals 0. That's all we ever have. Anytime you get any equation, like ever, somebody stops you on the street and says, how do you find a y-intercept? Just plug in x equals 0. Doesn't matter what equation. That's always how you find a y-intercept. Now the vertex has a nice little formula. The x value of the vertex is negative b over 2a, and then the y value is whatever you get when you plug it in. So let's create a little example and see how we do. We're going to go y equals x squared, let me turn it off, x squared plus 4x minus 7. So first, if we plug in x equals 0 for the y-intercept, we'll get y equals 0 squared plus 4 times 0 minus 7. That's just minus 7. In fact, a lot of people on standard form just memorize the number on the end as the y-intercept. And that's pretty easy to remember if you think about when we did mx plus b. The b on the end was the y-intercept. When we did exponential, the number that didn't touch the exponent was the y-intercept. And so in all these situations, the number that doesn't have a letter attached to it is just the y-intercept. It's the same thing here. It's not a different thing. It's the same concept, because plugging in x equals 0 just gives you the number that doesn't have a letter on it. Now let's get the x value of the vertex. Negative b over 2a. What the heck does that mean? Well, every standard form equation can be thought of as having some number of x squareds, which might be 1, some number of x's, which might be 0, and some number of constant numbers, which also might be 0, 1, anything in between. So when I say negative b over 2a, I mean look at the x term, which is 4x, take the 4 and put a negative in front of it. 2a means look at the x squared term, there's one of them, take the 1 and put a 2 in front of it. So that becomes negative 4 over 2 times 1, which is 2, which becomes negative 2. Now take the negative 2 and plug it into the equation. It's good practice sometimes to do this by hand, especially when the numbers are small, but you can also type this in. I'll show you doing it by hand. Negative 2 squared, I'm just looking at my equation, plugging in x, which is negative 2. Oops, typo. Like that. My pen is giving me trouble today, but I'm just plugging in negative 2 for all the x's. Negative 2 squared means negative 2 times itself. That's 4. 4 times negative 2, negative 8. Negative 7 is just hanging out. 4 minus 8, negative 4. Negative 4 minus 7, negative 11. So we know the vertex is going to be down here at negative 2, negative 11. All right, now is this going to be a happy face or a sad face? Well, the a value is positive, so I know it's going to be a happy face. Also, bonus, you know a parabola is symmetrical. So I know that if I went up 4 and 2 to the right, so if I'm at my vertex, remember this is my vertex down here. If I go up 4 and 2 to the right to get a point, I know I need to go up 4 and 2 to the left to get a mirror image point. It's a nice idea to do that, because then you have this nice symmetry that you can draw in. And I don't know where it hits the x-axis. It's probably not going to hit it at a nice number. Let's turn it on and see how we did. Pretty darn close. If you look at where it hits it, it's got these nasty numbers. That's why we're not focusing on it yet. I will note that those two numbers do add up to make 4, make negative 4. All right, let's do a harder example. I'm going to put like a -3 here and a 4.5 here, and we'll do a plus 1.7. Why not? So again, we're just going to do we're just going to do y-intercept and vertex. And this time I'm going to use my calculator because I made the numbers nastier. So the y-intercept, if I plug in 0 for x, I just get 1.7 for y. The x value of the vertex is just -b over 2a. Why don't we make that b value negative? That's a good thing to review. People always screw that up. Okay, so I made the b value negative now. So if I'm looking at -b over 2a, just please watch this. This part is sort of a pet peeve of mine. -b means negative b. I grabbed b exactly as it looked in the problem, and I put it into the parentheses. So -4.5 is in the parentheses. And then over 2a, I grab a exactly as it looks. Wow, my pen is really messing up. -2a. So it's -2 times 3. Okay. Double -4.5 is regular 4.5. Come on, pen. Don't fail me. 2 times -3 is -6. If you want, you can type that in. So when I typed it, I got -0.75. Come on, you can do it. -0.75. I take that and I plug it in. So watch how I type it in to the equation. I start by going -3 times x squared, so -0.75 squared, minus 4.5 times x, plus 1.7. So I just typed the whole darn thing in, all in one line with parentheses. And I got the y value is 3.3875. Beautiful. Let's see how we did. Check out the y-intercept. Exactly what we said, 1.7. Check out the vertex. Exactly what we said it would be. -0.75, 3.3875. X-intercepts are some nasty numbers that we don't need to worry about at this time. Okay, so that's standard form practice. Thank you for watching. Please let me know if you have any questions.